All right, so get ready for this, listeners. Today, today we're going to try something a little different. We're gonna take you behind the scenes of like a simulated job interview.
Oh, interesting.
Yeah, and not just any job interview, a data engineering architect position, like the high stakes, big company kind of role.
Oh, wow.
The folks who design and build the systems that pretty much power our data-driven world.
So it's like we're giving our listeners this exclusive, like all access pass to see what companies are really looking for when they're trying to find someone to build the backbone of their data infrastructure.
Exactly. Exactly. It's like a peek behind the curtain, right? You get to see what it takes to really impress those hiring managers and the challenges these candidates face.
Yeah. And we're not just talking about, basic data stuff here. We're talking about tackling real world problems, things like designing systems for millions of IoT devices,
Yep.
Handling real-time anomaly detection, like spotting those weird blips in the data that could signal a problem or maybe even an opportunity.
And all this while trying to navigate the complexities of a matrix organization, which, as you know, can be a bit of beast in itself.
Oh, absolutely. A whole other layer of complexity there.
So to really set the scene for you, imagine this, right? You walk into this interview room, and there's a panel of 3 interviewers just staring you down.
3.
Yeah, a chief data officer, a principal data architect, and an engineering director.
Talk about pressure.
I know, right? And right from the get-go, they want to know if you've got the goods, if you really know your stuff. They start grilling you on your experience with all those fancy data engineering technologies, the tools of the trade. And they also want to know how you approach designing these complex systems, the ones that can handle all that data and all those challenges we talked about.
Right, because it's not enough to just list a bunch of technologies on your resume.
No, not at all.
You need to show them that you understand how to actually use those technologies to solve real world business problems, that you can think critically and apply those tools effectively.
Absolutely. So let's jump right into the technical hot seat, shall we?
Let's do it.
Okay, so first up, they dive right into the world of big data.
Oh, yeah.
The kind of data that's so massive and complex that traditional tools just can't handle it. And they ask about Apache Spark.
Okay.
And why it might be preferred over the old school MapReduce.
Oh, that's a good one. That's a classic test to see if you understand the core concepts of big data processing.
Right. It's like a fundamental question in this field. And imagine you're the candidate. Could you handle that question?
Well, it depends, right? It depends on how well you understand the nuances of each technology and when to use one versus the other.
True. But let's say our candidate, they actually nail the explanation. They explain how Spark is, it's kind of like a race car, right?
A race car.
Yeah, think of it like this. It keeps all its data readily accessible in its memory, like right there at its fingertips.
So it's all about speed.
Exactly. It's incredibly fast, especially for those tasks that need to go back and forth over the data multiple times. Things like training those machine learning models we talked about earlier. And they contrast that with MapReduce, which is, it's more like a freight train.
Okay, I see.
It's powerful, right?
Mm-hmm.
It can move massive amounts of data, no problem.
Mm-hmm.
But it takes a lot longer for those tasks that require multiple passes over the data. Those iterative jobs.
Right, because it has to keep writing the data back to disk and then reading it again. That back and forth adds a lot of overhead.
Exactly. And our candidate, they're smart. They point out that, Spark isn't always the answer.
Right, it's not a magic bullet.
Yeah. There are times when MapReduce is still the better choice, especially when you're dealing with these absolutely massive data sets that just exceed the available memory, when that race car just can't carry all the cargo.
So it's about choosing the right tool for the job, understanding the strengths and weaknesses of each approach.
Right, exactly. And our candidate, they just keep impressing, They even go on to explain how Spark's unified APIs make it so versatile. They talk about how you can use it for batch processing, those big one-time jobs, but also real-time streams, that continuous flow of data, and even graph processing, which is all about analyzing relationships and connections in the data.
Oh, wow. So Spark can really handle a lot of different types of data processing tasks.
Yeah. Like they say, you name it, Spark can probably handle it.
Yeah.
And that versatility is a huge win for companies because it means they can use this consistent programming model, the same basic set of tools and languages.
How that simplifies things a lot.
Oh, absolutely. It simplifies development, it simplifies maintenance. It just makes everything a lot smoother. Can you imagine trying to manage like different tools and languages for every single type of data processing task.
Oh, that would be a nightmare.
It would be a total nightmare. Okay, so now here's where things get really interesting.
Oh, okay.
The interviewers, they decide to dig a little deeper. They really want to see what this candidate is made of.
Put them to the test.
Yeah, exactly. So they ask about the role of a Spark executor.
Spark executor.
Yeah, it's like they're peering under the hood of that race car we talked about earlier.
Oh, I see. They want to see how the engine works, not just how fast it can go.
Exactly. And this question really separates those who just kind of know the buzzwords
Oh, right.
from those who genuinely understand how Spark works, like down at a fundamental level.
The deep divers.
Exactly, the deep divers. And thankfully, our candidate, well, they handle it like a champ.
Okay, good.
They explain that executors, they're like these specialized workers within the Spark system.
Okay.
And each executor, it runs on its own separate machine.
Okay.
And it's responsible for processing a portion of that big data that we're talking about.
So it's like a distributed workforce.
Yeah, exactly. It's all about dividing and conquering, right? And Spark, it's smart. It tries to keep the data and the processing as close together as possible. It minimizes that need to shuffle data around the network, which, well, that would just slow things down tremendously.
Oh, yeah, like if you had to send a file across the internet every time you needed to work on it.
Exactly. And our candidate, they even go a step further. They mention how these executors, they manage their own little caches of data.
Caches.
Yeah, like, well, it's kind of like having a handy toolbox right next to your workstation, right?
Yeah.
If you need a particular tool over and over again, you keep it close at hand.
Oh, right, instead of running back and forth to the central storage every time.
Exactly. So those executors, they can quickly access those frequently used pieces of data without having to go fetch them from the main data store every single time.
So that makes those repetitive operations much, much faster.
Oh, yeah, way faster. And the kind of attention to detail, well, it really shows that the candidate understands the inner workings of Spark.
Yeah, not just a surface level understanding, but a real deep dive into how it all works.
Right. They're not just, name-dropping technologies. They're showing they understand the why and the how behind those technologies.
Exactly. It's like they're not just reading from the textbook. They're actually thinking about how to apply those concepts to solve real-world problems.
And that's what sets the really good candidates apart.
Yeah, the ones who can bridge that gap between theory and practice.
Okay, so next up, the interviewers, they kind of shift gears a little bit, They want to see if the candidate can handle the more hands-on aspects of data engineering.
Yeah, like actually building those systems, not just talking about them.
Exactly. So they throw a spotlight on data pipeline design.
Okay.
Which, well, that's like the backbone of any data-driven system, right?
It's like the circulatory system. It's how the data flows through the entire organization.
Right. You've got raw data coming in from all these different sources, and then it needs to be cleaned, transformed, like massaged into a usable format, and then delivered to wherever it needs to be.
And all of that has to happen seamlessly and reliably, even when you're dealing with massive amounts of data.
Oh, yeah. It's no small feat.
Yeah.
And designing a pipeline that's scalable, that's reliable, that performs well, that's a critical skill for any data engineering architect.
It's where the theoretical meets the practical.
Exactly. And to really test this, the interviewers, well, they present the candidate with a real-world scenario.
Okay.
And say, okay, imagine you need to design a system to process data from millions of IoT devices. Those smart devices that are pretty much everywhere these days.
Yeah, like smart thermostats, smart watches, connected cars, all that.
Yeah, all of that. And you need to detect anomalies in real time.
So like spotting those unusual patterns that could indicate a problem or maybe even a security breach.
Yeah, exactly. Think about the scale of that challenge. I mean, millions of devices, all streaming data constantly. And then you need to analyze that data, like on the fly, and spot those subtle anomalies that might be hidden within all that noise.
That's a lot to handle. That's a real test of your data engineering chops.
Oh, absolutely. But before jumping into solutions, the candidate does something really smart. They ask clarifying questions.
Okay, that's good. That shows they're thinking critically.
Yeah. They're not just assuming they know everything, They want to make sure they fully understand the scope of the problem.
So what kind of questions do they ask?
Well, things like, what's the expected volume of data? We're talking about like gigabytes per second, terabytes per day. What are we dealing with?
Makes sense.
And then what are the latency requirements? How quickly do we need to detect these anomalies? Are we talking milliseconds, seconds, minutes? What's the acceptable delay?
Oh, right. Because some use cases might require super fast responses, while others might have a little more leeway.
Exactly, exactly. And then what format is the data in? Is it structured, unstructured, semi-structured?
Hmm.
Are we dealing with like JSON blobs, CSV files? What are we looking at?
All important details that can influence the design of the system.
And of course, are there any compliance issues? Do we need to worry about data privacy, data security, any kind of regulations that might affect our design choices?
Yeah, can't forget about those.
Definitely not. And by asking all these questions, the candidate is showing that they're thinking carefully, they're not making assumptions, and they're really trying to get a holistic view of the problem.
It's like a detective gathering clues before forming a hypothesis.
Right. You got to understand the full picture before you can start piecing together the solution.
So what solution do they come up with?
Well, let's just say it's impressive. They propose a Lambda architecture.
Lambda architecture.
Yeah, yeah. Which is, well, it's kind of like having different lanes for data processing, right?
The lanes.
Yeah, yeah. Like a fast lane for those real-time insights, those quick decisions that need to be made on the spot.
Okay.
And then a slower, more thorough lane for the historical analysis.
So it's like you're processing the data in two different ways simultaneously.
Exactly.
Yeah.
Exactly. And that's the beauty of the Lambda architecture. It recognizes that, sometimes you need that immediate insight, that quick response. But then other times you need to take a step back, look at the bigger picture, analyze trends over time.
So it's like having the best of both worlds, right?
Yeah, yeah, exactly. You get that real-time responsiveness and you get the depth of historical analysis.
Okay, so how does this Lambda architecture actually work in practice? Like, what are the components of this system?
Okay, so let's take a peek under the hood, right?
Let's do it.
So for data injection, which is, well, that's the process of bringing the data into the system, they choose Apache Kafka.
Kafka.
Yeah, yeah. Which is, well, it's known for its ability to handle like massive streams of data. Think about all those millions of IoT devices we talked about earlier.
Right, each one sending a constant stream of data points.
Exactly, exactly. And Kafka, it's like the central nervous system of the whole system, right?
Yeah.
It reliably collects all that data from those devices, and then it distributes it to different parts of the system without missing a beat.
So even if one part of the system, hiccups or goes down temporarily,
Yeah.
Kafka can keep that data flowing smoothly.
Exactly, exactly. It's like a really, really reliable messaging system.
Right.
Okay.
So that takes care of getting the data into the system.
Right.
But then what about processing it?
Okay, so to handle the real-time processing, they recommend using either Spark streaming or Kafka streams.
Spark streaming or Kafka streams. Okay.
Yeah. And those are both technologies that are, well, they're built for speed.
So they can handle those real-time anomaly detection tasks we talked about.
Exactly. Exactly. They allow you to analyze that data with like sub-second latency, which is, well, that's perfect for catching those anomalies in the nick of time.
So it's like a security system that can detect a break-in as it's happening.
Yeah, yeah, exactly. Rather than, after the fact when it's too late.
Right, right. So you can take action immediately to prevent the problem from getting worse.
Exactly, exactly. Okay, so now we've got the data throwing into the system. We've got the real-time processing happening. But then where does all this data go? Where do we store it all?
Good question.
And for that, the candidate proposes a tiered storage strategy.
Tiered storage.
Yeah, yeah. Which is, well, it's kind of like having different types of memory in a computer system, right?
Okay. Like RAM for fast access and then a hard drive for long-term storage.
Exactly, exactly. So the hot data, which is, well, that's the information that needs to be accessed like immediately, that goes into an in-memory store, like Redis.
Redis, okay.
Yeah, which is, well, it's super fast, right? It's like your system's short-term memory, just providing that instant access to that critical information.
Okay, and what about data that's not needed like right this second, but is still important for, for operational analytics and reporting?
Right, right. So that kind of data, like recent sales data or website traffic, things like that, well, that might go into a columnar database like ClickHouse.
ClickHouse.
Yeah, which is, well, it's specifically designed for handling like time series data really efficiently.
So it's optimized for storing and querying data that's organized by time, like sensor readings or stock prices.
Exactly, exactly. It's like your system's more persistent memory, right?
Yeah.
It's storing data that needs to be readily available for analysis, for reporting, for those kinds of tasks.
Okay, makes sense. So what about long-term storage and historical analysis?
Right, right. So for that, well, that's where the data lake comes in.
Data lake.
Yeah, which is, well, it's basically a massive storage repository that can hold just about any kind of data.
And where would you typically build a data lake?
Well, they're often built on cloud storage platforms like Amazon S3,
There's three.
and they often use file formats like Parquet, which is well, it's designed for cost-effective storage and efficient querying.
So it's like the system's long-term memory. It's where all that historical data is archived.
Yeah, yeah, and it can be accessed for deeper insights, trend analysis, machine learning, model training, all those kinds of things.
Okay, but we're not done yet, right? The candidate has more up their sleeve.
Oh yeah, they're not done yet. They highlight the importance of scheduled batch processing, right? Using Spark to run more complex analyses.
So like those big one-time jobs that don't need to be done in real time.
Exactly, exactly. Like retraining models or generating aggregate metrics, things like that.
Okay, and why is that important?
Well, it ensures a consistent view of the data.
Consistent.
Yeah, yeah. Like whether you're looking at the real-time insights or the historical trends, you want to make sure that the data you're using is consistent.
Oh, right. So you're not getting different answers depending on which part of the system you're looking
Yeah,
at.
exactly, exactly. And then, of course, no data system is complete without considering deployment and reproducibility, right?
Right, because you need to be able to actually build and deploy the system and then make sure that it can be easily replicated and scaled as needed.
Exactly. And for that, our candidate advocates for containerization with Kubernetes.
Kubernetes.
Yeah, which is, well, it's basically a way to package up your software and its dependencies into these portable containers.
Oh, okay.
And then infrastructure as code, which is, well, it's like having a blueprint for your entire development. All the configuration files, all the scripts, everything you need to deploy and manage that system in a consistent and repeatable way.
So it's like having a set of instructions for building a Lego model. You can just follow those instructions and you'll get the same result every time.
Yeah, yeah, exactly. And that makes it much easier to deploy the system, to scale it, to manage it over time.
Okay. And to top it all off, they emphasize the need for comprehensive monitoring at each stage of the pipeline.
Oh, yeah, absolutely.
Because
Yeah.
you need to know what's going on in the system, right? You need to be able to spot any problems before they become major issues.
Right. It's like having a network of sensors and alarms throughout the entire pipeline. They're constantly checking the flow of data, the performance of the system, and if anything goes wrong, well, you get alerted immediately.
So you can proactively address those problems before they impact your users or your business.
Exactly. Exactly. It's all about being proactive rather than reactive, right?
So they've nailed the design of this complex data pipeline. They've thought about everything from data ingestion to real-time processing to storage to deployment to monitoring. It's really impressive.
It is. But, well, the interviewers aren't done yet.
Oh, no.
No. They want to see if the candidate can handle the unexpected.
The curveballs.
Yeah, the curveballs. So they ask, what happens when the system gets overloaded? What if there's just too much data coming in or the processing can't keep up?
Oh, right. Because in the real world, things don't always go according to plan.
No, they don't. And that's what this question is really getting at. It's testing the candidate's ability to think about those real-world constraints, and design systems that are resilient, that can handle those unexpected challenges.
So it's not just about building a system that works in theory.
No.
It's about building a system that works in practice, even when things go wrong.
Exactly. So they specifically ask, imagine your hardware is limited,
Yeah.
right? And you can't process a microbatch in time.
Microbatch.
Yeah. Basically a small chunk of data that gets processed together.
Okay.
So they're saying, okay, what if you just can't process that microbatch in the allotted time? How do you handle that back pressure?
Back pressure.
Yeah. It's like it's like when water is trying to flow through a narrow pipe, right?
Mm.
And it creates pressure, and if that pressure gets too high, well, something's got to give.
Right. Either the pipe bursts, or you got to find a way to release some of that pressure.
Exactly, exactly. And that's what backpressure is all about in data systems. It's when
Hmm.
the data is coming in faster than you can process it, and you need to find a way to manage that flow to prevent the system from, well, from crashing.
So how does the candidate propose to handle that back pressure?
Well, thankfully, they've got a really, really level-headed, multi-layered strategy.
Okay, let's hear it. Okay, so we're back, and our candidates got their game face on, ready to tackle this last challenge. They've impressed us with their technical knowledge and real-world experience, but now it's time for the final boss, data deduplication.
And this isn't just some theoretical puzzle, right? This is a real-world problem that anyone working with massive data sets has to deal with. Imagine you've got data pouring in from all these different sources, and you've got duplicates, those sneaky little data gremlins, hiding everywhere.
Yeah, they can really mess things up. They can skew your analysis, make you think you've got more data than you really do, even lead to bad business decisions. It's like trying to count a crowd, but you keep counting the same people over and over again.
Exactly. And that's why data deduplication is so important. It's about cleaning up that mess, getting rid of those duplicate records, and ensuring that you're working with clean, accurate data.
So the interviewers throw this challenge at the candidate. How would you design a system to efficiently deduplicate large volumes of data before it even reaches the data warehouse? So it's like catching those duplicates at the source before they can even get in and cause trouble.
Right, preventing them from messing up your analysis and your reports downstream.
Mm.
And our candidate, well, they don't miss a beat. They start by explaining that there's no one-size-fits-all solution. The best approach depends on the specific requirements, like whether you need exact matching or fuzzy matching.
Right, because sometimes you need to find records that are identical, like two entries with the exact same customer ID and purchase history. But other times you need to identify records that are similar but not exactly the same, like two customer records with slightly different names but the same address.
Exactly. So for exact matching on structured data, the candidate suggests a hash-based approach. Basically, you assign each record a unique fingerprint based on its key characteristics.
It's like giving each data point its own ID card.
Right. And if two records have the same fingerprint, well, they're likely duplicates. And for smaller data sets, the candidate mentions Spark's built-in drop duplicates function. It does exactly what it says, finds those duplicates and kicks them out.
It's like a bouncer at a club, making sure only the unique records get in.
But for massive data sets, things get a little more complicated. You can't just compare every record to every other record. That would take forever. So the candidate suggests a more optimized approach using a combination of partitioning and sorting. It's like sorting your Lego collection by color before building a specific model, right? Makes things a lot easier.
Makes sense. So you divide the data into smaller chunks based on those hash values or fingerprints, and then sort those chunks to bring potential duplicates together, making the deduplication process way more efficient.
You got it. And for those truly ginormous data sets, they introduced the concept of window deduplication. Basically, you maintain a sliding window of recent records and only check new records against this window.
So you're not constantly comparing against the entire history of the data, just a smaller, more recent subset. That's clever.
Right. Saves a ton of time and computing power. But exact matching isn't always enough, especially when you're dealing with those fuzzy matches we talked about earlier. For those cases, our candidate brings out the big guns techniques, like locality-sensitive hashing and edit distance metrics.
So locality-sensitive hashing is like grouping your data points based on how similar they are, like clustering all the cat photos together and all the dog photos together. And then you can use edit distance metrics to see how many changes it takes to transform one data point into another, which helps you figure out if they're actually the same thing.
You explained it perfectly. And no matter which method they choose, our candidate emphasizes the importance of performance optimization. They talk about parallelizing the process, partitioning the data smartly, and pre-filtering to reduce the number of comparisons needed. It's all about working smarter, not harder.
They're thinking like a true data engineer, optimizing for efficiency and scalability.
And of course, they stress the importance of logging and monitoring the whole process to track performance and make sure those duplicates are actually being caught. It's like setting up a security camera to make sure no one's sneaking back in.
Right. Always good to have that extra layer of protection. So our candidate has pretty much aced every technical challenge thrown their way. They've shown a deep understanding of data engineering principles and a real talent for solving those tricky data problems. But the interviewers have one final question, and it's a big one. They ask, what are the overarching principles that guide your architectural decisions?
It's like they're asking, what's your data philosophy? What are the core values that shape the way you build and design systems?
It's a chance for the candidate to show that they're not just a code monkey, but a true data visionary, someone who understands the bigger picture.
And our candidate delivers. They lay out their core principles, starting with business alignment. They believe that technology should serve the needs of the business, not the other way around. It's about building solutions that deliver real value, not just cool tech for the sake of cool tech.
It's about being a partner to the business, understanding their goals and challenges, and finding ways to use data to help them succeed.
Their next principle is scalability by design. They believe in building systems that can handle growth from day one, even if current volumes don't demand it. It's about thinking ahead, anticipating future needs, and making sure the system can adapt and scale without breaking a sweat.
It's like building a foundation that can support a skyscraper, even if you're only planning to build a one-story house right now.
Right. They also emphasize operational excellence, which is all about building systems that are easy to monitor, troubleshoot, and maintain. It's about making sure that the system is not only functional, but also reliable, manageable, and adaptable to change.
It's like building a car that's not only fast, but also safe, fuel efficient, and easy to repair.
Perfect analogy. And their next principle is all about choosing the right tool for the job. They believe in a pragmatic approach, balancing innovation with practicality. They're not afraid to try new technologies, but they also understand that sometimes the tried and true solutions are the best.
It's about being a master craftsman, knowing which tool to reach for depending on the task at hand.
And finally, they highlight the importance of empowered teams. They believe that architecture should enable teams to work independently while still maintaining system cohesion. It's about fostering collaboration and ownership, creating an environment where teams can thrive and do their best work.
It's like creating a well-oiled machine where each part works seamlessly with the others, but each part also has its own autonomy and responsibility.
Well, there you have it, folks. Our candidate has aced the interview, showcasing their technical brilliance, their problem-solving skills, their leadership qualities, and their deep understanding of what it takes to build and manage world-class data systems. They've impressed the interviewers, and I think they've impressed our listeners, too.
They've certainly raised the bar for what it means to be a data engineering architect.
They've given us a glimpse into the exciting world of data engineering, the challenges and opportunities of working with data at scale, and the incredible impact these systems have on our lives.
So as we wrap up this deep dive, think about the systems you interact with every day. The apps on your phone, the websites you visit, the services you rely on. They're all powered by data, and behind that data are talented engineers who are designing, building, and managing those complex systems. It's a fascinating field, and it's only going to get more important as data continues to shape our world.
So we want to hear from you, listeners. What were your takeaways in this episode? What surprised you? What inspired you? Share your thoughts on social media using #TheDeepDive, and let's keep the conversation going. And as always, stay curious.